Assalamu alaikum.
Walaikum assalam, sir.
How are you, Hamza?
Alhamdulillah, fine, sir. How are you?
Alhamdulillah, fine. Do you have any doubt from last class?
No, sir.
Okay. We had just started mechanical properties of solid, in which I had defined you about longitudinal stress, strain, and Young's modulus. Let me give you a numerical related to this. A wire having length 2 meters, area of cross section 4 mm square is hanged vertically. If a force of 20 kilonewton is applied to elongate it, find longitudinal stress strain if Young's modulus is 2 into 10 to the power 11 Newton per meter square, and third, elongation produced. First, write all the given quantity in terms of their SI unit, and then apply the formula and simplify it. Try to solve. Hamza, any problem while solving?
Sir, not yet.
Okay. Salman, you got any answer?
Sir, I'm quite stuck.
Okay. Let's say we have length as 2 meter. Area of cross section is 4 mm squared. So to convert it into meter, just multiply it by 10 to the power minus 6. Force is 20 kilonewton, which is not an SI unit. So just multiply it by 10 to the power 3 to convert it into Newton. Young's modulus is 2 into 10 to the power 11 Newton per meter squared. Now, first formula is for calculating stress. Stress equals to deforming force over area of cross section. Put the value of these two terms and simplify it. Next is Young's modulus equals to stress divided by strain. We have Young's modulus and a stress. So rearrange this equation to find strain from this part. And then strain equals to delta L divided by L. You can calculate delta L using these two terms. Try to simplify it. Suppose in first part, we have force as 20 into 10 to the power 3. Area of cross section is 4 mm squared. So 4 into 10 to the power minus 6. So 4 in 5 times, it will be 20. Move this 10 to the power minus 6 to numerator, it will become plus 6. So you'll get 5 into 10 to the power plus 9 Newton per meter square as stress. Hamza, is it clear?
Yes, sir.
Was it so difficult to simplify?
No, sir, I got this answer, but like it was not in this form. Like
Okay, no problem.
I took 20,000 instead of 20 into 10 to the power 3.
Okay. Next is using this relation, we may find strain. So move this strain to left side and Young's modulus to right side. So strain equals to stress divided by Young's modulus. Stress is 5 into 10 to the power 9 and Young's modulus is 2 into 10 to the power 11. So 5 by 2, it will be 2.5 and 10 to the power 11 on moving to numerator, it will become minus 11. So 9 minus 11 will be minus 2. And strain is unitless quantity, so it will be as it is. Using third equation, delta L equals to L times strain. L is 2 meter, delta or strain is 2.5 into 10 to the power minus 2. So it will be 5 into 10 to the power minus 2 in terms of meter, or in terms of centimeter, it will be just 5 centimeter. Salman, is it clear?
Yes, sir.
Okay. Hiba, any doubt?
No, sir.
Salman, you have written?
Done, sir.
Yes, sir, done.
Okay. Next is, or second type is tangential or shear. Suppose you have a cylindrical body placed vertically on a rigid support such that its base is fixed. On applying tangential force on its top surface, it may bend like this. So if a force is applied tangentially along this direction, due to applying this tangential force, there is deformation in its shape from this point to this point, let's say X. Length of this particular cylinder is L. Corresponding to this shift, there is change or bending by some angle theta. So area of cross section in this part over which force is acting is this term. So shear stress or tangential stress equals to tangential force acting per unit area. This force should be tangential. Corresponding deformation in it will be called as shear strain, and it will be just theta, or theta equals to x by L, since sine theta equals to tan theta equals to theta if theta is small. And tan theta is perpendicular by base. So in this part, perpendicular is x, base is L. So theta will be x by L. Now, if you divide these two terms to define modulus of elasticity, in this term, it is called shear modulus. So shear modulus equals to shear stress divided by shear strain. Shear modulus is denoted by G or sometimes eta equals to shear stress F divided by area of cross section whole divided by theta, or you may rearrange it F times L divided by A times X. This particular G or shear modulus will also define modulus of or elasticity of a particular body in shape, as by applying this tangential force, there is deformation along shape of this particular body. So we may call this G as elasticity in shape. And shape is defined only for solid. So this shear modulus will define only for solid. Hamza, is it clear?
Yes, sir.
Okay, just write it down.
And so,
Salman,
done, sir. Done.
okay. A cube having side 10 centimeter is fixed on surface. A force of 40 kilonewton is applied tangentially to its top face. Find shear stress, shear strain if eta is 4 into 10 to the power 8 Newton per meter squared. Just use the above formula and try to find. Suppose you have a cube like this, having side 10 centimeter, and a force is applied tangentially along this direction, due to which there is deformation in it. Try to find.
Sir, can you show the up part again? Because I had to take screenshot for Khalid, like the notes part. No, tangential, shear, and that part. Down one.
You may send your notes to him.
No, like my handwriting is problem. That's why.
Okay. From this part,
Yes, sir. Yes, sir. Wait a second, sir. I didn't take screenshot of this up part.
Yeah, I took this. The down one, tangential slash stress. Shear, sorry, shear.
Done?
Sir, the down one, sir, little bit down. This one, tangential stressful. Okay, sir. Thank you, sir.
Hamza, you got any answer?
Almost near, sir.
We have side of Q as 10 centimeter. So area as each face of Q will behave as square. So area will be side square. So it will be 10 divided by 100 in terms of meter, 10 divided by 100 in terms of meter. So it will be just 10 to the power minus 2 meters squared. Force is 40 kilonewton. So just multiplied by 10 to the power 3 Newton. So shear stress equals to deforming force or tangential force over area of cross section. Tangential force is 40 into 10 to the power 3. Area of cross section is 10 to the power minus 2. So move this term to numerator, you will get 4 into 10 to the power 134 plus 2, 6 Newton per meter squared. Hamza, is it clear?
Yes, sir.
So from where you have got this result?
Sir, I took 10 minus 10 raised to the minus 2 wrong.
Okay. Salman, is it clear?
Yes, sir. After this one, like shear stress F by A formula, that one I made wrong. I wrote
Okay.
theta something.
So next is shear modulus eta equals to shear stress divided by shear strain. So shear strain is denoted by theta equals to shear stress divided by shear modulus. Shear stress we have calculated as 4 into 10 raised power 6 and shear modulus is 4 into 10 raised power 8. So you will get 10 to the power minus 2 only, and it will be unitless quantity. Hiba, is it clear?
Yes, sir.
You all have written?
Yes, sir.
Salman, done?
Yes, sir. Done.
Now, there will be some problem related to string. Let me define a concept behind it. Suppose you have two different blocks. This block having mass 2 kg, this block having mass 3 kg. If rods are identical, find ratio of longitudinal stress produced in them. Let me define you how to approach this problem. First, for stress, we must need two different terms, deforming force, and second is area of cross section. So first thing, what will be the possible factor which will be responsible for deformation in this particular rod or wire? Hamza, any idea? Which particular factor will be responsible for applying deforming force to the system? You will say this attached block which having some mass which must be experiencing a downward gravity. So there will be force at this point due to this 3 kg block, mass times gravity. Is it clear?
Yes, sir.
Now, if a wire rope gets straightened due to applying some force to it, so there will be some tension developed into it. So it must act opposite to this point of contact. Let's say this is T1. Is this particular block will move downward or upward? So you'll say no, as this whole system is at rest. Since there is no movement of this particular block upward or downward, so net force on it at this instant should be 0. So total upward force must be equals to total downward force. So we have total upward force as T1 and total downward force as 3 times gravity. And due to this particular tension T1, there will be deforming force acting in this particular string. So deforming force in this particular wire will be nothing but just T1 due to the block attached below it. Hiba, is it clear?
Yes, sir.
Similarly, we may define tension at this particular point for the upper part. There will be tension in downward direction as T1 due to the straightness of this particular string. And there will be another force due to its own mass as 2g in downward direction. Now to compensate it, there will be tension in this upper string as T2. Now total upward force equals to total downward force. Total upward force is T2. It should be equals to total downward force, that is 2 times of gravity plus T1. We have T1 as 3 times G, so 3 plus 2 in total will be 5 times G. Salman, is it clear?
Yes, sir.
Is it clear to this part?
Yeah.
Now, on the basis of this deforming force, we may define stress. Let's say this is wire first, A, this is wire second, B. So stress in first wire equals to deforming force in first, that will be T2, by area of cross section. Stress in second wire B equals to deforming force, that will be due to tension T1 by area of cross section. Now, if you divide these two terms to take ratio, since rods are identical, it means length of each rod will be equal and area of cross section as well. So area and area will cancel out, put the value of T1 and T2 and simplify it. Try to solve. Hamza, you got any answer? Good. we have to define the ratio. So it should be written in fraction only. So area and area will cancel out. So you'll get T2 divided by T1. T2 is 5 times gravity and T1 is 3 times the gravity. So G and G will cancel out. So you will get 5:3. Salman, is it clear?
Yes, sir, clear.
Okay. Hiba, any doubt?
No, sir.
Okay. Salman, you have written?
Yes, sir, done.
Now, third type of deformation will be volumetric or hydraulic. Suppose you have spherical body. And if pressure or force is applied from its all side, due to this application of force from its all side, there will be change in its volume. So it may acquire this particular volume finally, or it may get compressed. So initial volume is this part. Finally, it will become this on applying force from all side. Since this particular force will be perpendicular to the point of contact to the surface. So at this point, it will be normal to it. This point, and this point also. So if a force is applied on a particular object perpendicular to it, then we call it as pressure. So first is volumetric stress. Perpendicular force acting per unit area, which will be also termed as pressure exerted on this particular object. Now, due to the application of this pressure, there is change in volume, in which final volume is smaller as compared to initial volume. So difference of volume will be equals to V final minus V initial. And since final is smaller as compared to initial, so there will be negative sign. So next part will be volumetric strain. Change in volume divided by initial volume. Since this particular change is a negative sign, so there will be negative sign. Now, if we divide these two terms to define modulus of elasticity, in this volumetric part, it is called bulk modulus. So bulk modulus equals to volumetric stress divided by volumetric strain. Bulk modulus is denoted by beta. Volumetric stress we have calculated as pressure divided by volumetric strain as delta V by V. So on rearranging, you will get P times V divided by delta V. Is it clear?
Yes, sir.
Since this particular bulk modulus is defined along volumetric to this particular object, and volume is defined for all different medium, so we can call it as this bulk modulus is defined for all medium, all particle. It is defined for all medium or body. This beta is also called elasticity or modulus of rigidity.
Done, sir.
Done, sir.
On applying 20 atm pressure on a spherical body, its volume get decreased by 0.5%. Find volumetric strain and bulk modulus. Let me define you how to approach this part. We have first pressure applied to this particular body is 20 atm. So P is equals to 20 atm. 1 at atm equals to 10 to the power 5 Pascal. So we may write it as 20 into 10 to the power 5 Pascal. As 1 atm pressure equals to 1.013 into 10 to the power 5 Pascal, or you may write it as just 10 to the power 5 Pascal. Next is decrease in volume by 0.5%. Percentage of particular quantity may be defined as change in quantity divided by initial quantity into 100. This is called percentage of that particular quantity. It is equals to 0.5%. So move this 100 to right side. So it will be delta V divided by V equals to 0.5 divided by 100. And I have put negative sign here as it is decreasing. Hamza, is it clear?
Yes, sir.
Now put the formula to find bulk modulus. Hamza, just check your calculation. You have done a little mistake. Salman, you got any answer? Let me solve. Bulk modulus equals to minus of pressure divided by delta V by V. Pressure we have given 20 into 10 to the power 5, and delta V by V is minus of 0.5 divided by 100. So this minus and this minus will cancel out. This 100 will move to numerator. So it will become 20 into 10 to the power 5 into 10 to the power 2 divided by 0.5. So remove this decimal, then there will be 10. 2 or 5 in 2 times will be 10. So 2 into 20 will be 40. Or we may write it as 4 into 10 to the power 1056 plus 2, 80 Newton per meter square. And since in this part, this will be normal to that particular surface, so we may write it as 4 into 10 to the power 8 Pascal. Hamza, is it clear?
Yes, sir.
Iba, any doubt?
No, sir.
Salman?
Yes,
No,
sir.
but my answer was also right. I mean, okay, like there was just negative sign. I've given minus 40 into 10 to the power
Yeah.
7.
You have to just neglect these two minus or just cancel
Yes,
out these
actually, I
terms.
didn't take minus 20 into 10 to the power 5. That's why I got minus there.
Okay, no problem. Now, next term is how to calculate fractional change in radius by applying some pressure on it. We can write volume equals to 4 by 3 pi r cube. We have exponential of this particular volume as 1 and exponential of this r 3. So according to the rule of exponential, we can write it as delta V by V equals to 4 by 3 pi is constant, so just neglect it. R raised to 3, so the exponential of it will move to its coefficient. So we may write it as delta R by R. Is it clear? Hamza, is it
Yes,
clear?
sir.
Yes, sir.
Okay. Let me define your question related to this part. Suppose there is a tank in which liquid is filled up to this level and there is a piston over it. On which there is a block having mass m. If area of this particular piston is A, and suppose a sphere of radius r is placed into it. It is being surrounded by liquid. So you'll be asked, find fractional change in radius of sphere. So how to calculate this particular fractional change in radius of this particular sphere? So to apply this particular formula of bulk modulus, you must need some external agency which will be responsible for applying pressure on this particular entire system. Hamza, which will be the influencing factor or factor which is responsible for applying pressure?
The force.
Yes. Tell me again.
Sir, maybe force.
Force from where?
From above.
Due to block. You may say this particular block may be attracted by gravity towards downward direction. So there will be force on it, mg, which must be applied over this particular piston, which is spread over this particular amount of area, A. So there will be some pressure due to this application of force. So pressure equals to force by area of cross section. So force is mass times gravity, area of cross section is A. So we have calculated pressure. Now, according to the formula, beta equals to pressure divided by delta V by V. Put the value of these two terms, delta V by V as this part and pressure as this part, and try to find delta R by R. Okay? Try to solve.
Yeah.
Hamza, we have to calculate fractional change in radius. So beta will be as it is. Pressure is mg by A. Delta V by V is 3 times delta R by R. So move this delta R by R to left side and beta to right side. So you will get delta R by R equals to mg divided by 3 times beta into A. So this will be our final expression. Okay.
Yes, sir.
Salman, any doubt?
No, sir. No doubt.
Okay. You will have written.
Yes, sir.
Hiba, done?
Yes, sir.
Okay. Next is, there will be some typical question on the basis of this above explanation. First is, for perfectly rigid body, there will be no deformation along its length, along its area, or along its volume. So deformation in this part will be 0. And according to the formula, Young's modulus equals to F times L divided by A times delta L. So if you put the value of delta L to be 0, you will get number divided by 0. So any number divided by 0 will be nothing but infinite. So Young's modulus in this case will be infinite. Similarly, shear modulus or bulk modulus will be infinite in this case. So you will be asked to define for perfectly rigid body, what should be the numerical value for modulus of elasticity. So you'll say it should be infinite. Is it clear?
Sir, but any number divided by 0 is not possible, right?
It was up to class 10th or below that. Okay. Now you
Okay,
are
sir.
in 11th class. So if a number divided by 0 will be infinite, or you will say its maximum limit. Okay.
Yes, sir.
Next question will be, which is more elastic? They will give you some pair. Let's say first is between steel and rubber. Next pair will be water and gas. So you have to define elastic or elasticity of these quantity or this particular substance on the basis of numerical concept or numerically or mathematically. So let me define you how to approach this question. So first, you'll say, take identical piece of these two substances attached to any particular support. let's say there is support from which identical segment of this substance this is rubber having length L, area of cross section A, steel having length L, area of cross section A is attached. Now, if you apply same force on either one of them, same force is applied, same force is applied. Now, which do you think, or in which part do you think there will be more deformation, in rubber or steel?
The rubber.
Good. So there will be more deformation in rubber as compared to steel. So let's say deformation in this rubber will be till this point, delta L in rubber, and in steel, it will be just to this point only. So if identical segment of rubber and steel is attached to support and same force is applied, then deformation in rubber will be greater as compared to steel. And according to the formula, Young's modulus equals to force times length divided by area times delta L. It means Young's modulus is inversely proportional to deformation in it. So we can say rubber has more deformation as compared to steel. So rubber will have lesser value of Young's modulus as compared to steel. So Young's modulus in steel will be more as compared to rubber. And Young's modulus or any modulus of elasticity simply defines you the elastic behavior of that particular substance. Hence, we can conclude elastic or steel is more elastic as compared to rubber. Hence, steel is more elastic than rubber. Hiba, is it clear?
Yes, sir.
Salman, any doubt?
No, sir, no doubt. Can you show the question? I didn't write it. The
Okay.
answer. The answer, sir.
You may write it from here.
Writing. Yeah, okay, sir. Thank you. Done, sir.
Done, sir.
Similarly, in next part, in terms of water and gas, which is fluid. So we can't define its shape or length. So take equal volume of them in a balloon. So in second part, take equal volume of water and gas like this. Now, if you apply same pressure on both of them, in which case do you think there will be more deformation volume? Iba?
Gas.
Okay, good. So we'll say for equal volume of water and gas on applying same pressure, change in volume in gas will be greater as compared to water. Therefore, beta in water will be more as compared to gas. Hence, water will be more elastic. So on the basis of this way, we can define elasticity of any different pair. Okay. Hamza, any doubt?
No, sir, no doubt.
Okay, just write it down.
Answer.
Salman, you have written?
Yes, sir, I have written.
Okay. So this is all about stress, strain, and deformation part. Next is stress, strain curve. You'll be asked to define this particular curve and plot its different point. Suppose there is a rod attached to vertical support like this, and a deforming force is applied along this direction to elongate it. So in first part, if you apply stress to reach at this point A. This is applied stress, and this is corresponding strain develop into it. So if you stretch this particular rod up to this point A, and deforming force is removed at this point A, so this object have ability to go back to acquire exact configuration as it was initially. Is it clear?
Yes, sir.
Now, if you stretch a little bit more to reach at point B, and now remove deforming force from it. So it may have ability to go back, but now it will reach to some different point. Let's say this point. It means it have still property of elasticity. So it may regain its shape, but with some permanent deformation with it. That is from this point to this point, which is called permanent set. And it will be about 1 to 2% of its total length. Is it clear?
Yes, sir.
Salman, any doubt?
No, sir, no doubt.
Now, if you further apply or increase deforming force on this particular wire, so it may follow this path to reach at this point C. During this, from B to C, if deforming force is removed, this body will have lose their ability of regaining their original shape, that is, lost their ability of elastic behavior. And it may have entered into some new property that is called plastic. So this is called plastic region, in which there will be no behavior of elasticity in it. At this particular point C, object having tendency to withhold maximum stress on it. So this point is also called ultimate stress. Hiba, any doubt?
No, sir.
Okay. Now, on applying a little bit more stress to this particular point C, object will tend to flow. And at any point D, it may break. So this point D is called breaking point. And from C to D, body will have tendency to flow. So during this particular region, between C to D, geometry of this particular object will be like this. Jelly-like behavior. So at any contradiction, let's say this point or at this point, it may break. Salman, is it clear? Hamza, any doubt?
No, sir, no doubt.
Okay. Now from O to A is the state or limit up to which Hooke's law will be valid. So this is called elastic limit. So only this region between O to A, Hooke's law will be valid. This particular point B is the point up to which body will have some elastic behavior. So it is called yield point. And from O to B, object having tendency to regain its shape. So this is called elastic region. Similarly, if you compress this particular object, so it may acquire this same curve, but in opposite direction. So first it will reach to this point A, then it will reach to B, then to C, and start flowing. And at any point D, it may get fractured. So this is called compressile stress. And this is corresponding strain. You'll be asked only this particular part, tensile stress or longitudinal stress. Just draw this, then I will define you each segment. You all have written?
Yes, sir.
So first is from O to A. If deforming force is removed, object will acquire its original shape exactly. Within this region, Hooke's law will be valid. Within this region, Hooke's law will be valid. So this may be called as elastic limit. Next, A to B. If deforming force is removed, object will tend to acquire its original shape, but with some permanent deformation. Which is called permanent set. Next, between B to C, object will have no longer elastic behavior. And having plastic nature. And from C to D, on applying very small stress, it may start to flow, and at any Hamza, is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Okay. Now, on the basis of this particular curve, we may define property of a particular material. First is ductility, malleability, and brittle. Hiba, do you have any idea about these terms? You must have learned these terms in class 10 or class 8 in chapter metal, non-metal. Hamza,
So the state of being ductile, like in wire or thread or something.
good. Malleability, You must have used silver foil,
Maybe some
gold foil.
solid, something related to solid, like the state of being solid.
Okay, let me define. Ductility is to be drawn into thin wires on beating or on applying pressure. So property of material to be drawn into thin wires. Malleability is the property of material to be drawn into thin sheets. And brittle is property of glass. If you apply some pressure or force, it may get broken into pieces. To be broken into pieces on applying force. Now, related to this stress strain curve,